Good morning. Today we will start with a new topic. Before proceeding towards the numerical side, let us first start to understand what do you mean by a free body diagram. This is the most important point in this particular topic, as if you make this free body diagram wrong, the entire numerical will become wrong and you will get 0 marks. So let us first try to understand what do you mean by free body diagram and how to draw free body diagram. What are the forces to be shown under the free body diagram? The first thing is, what do you mean by a free body diagram? So basically, free body diagram is when you draw a body relieving or removing all the supports from which it is supported. For example, let us say this in this figure number 1, this particular ladder is being supported at this particular point B and this particular point A. So now if I remove these supports and draw the diagram, that will be known as the free body diagram of that ladder. So let us start with drawing the free body diagram. So first I will remove all the supports and draw the ladder like this. So this is a ladder which is at point starting at A and going up to B. Now, how to draw the free body diagram, or you can say what are the forces to be considered while drawing free body diagram. So the first force which we consider while drawing the free body diagram is the applied force. The force which is shown or which is applied on the body. So if I observe this figure carefully, there is no applied force which is applied on this particular body. So we will not make any applied force. Second force which we are going to show in the free body diagram is the self-weight. Self-weight, just remember that self-weight to be shown always vertically downwards and at the center. So if I take the center of this rod AB or this ladder AB, center will be somewhere here and the weight will be shown perfectly in vertical direction. So this is your weight W. So first force was applied force. As there is no applied force in the body, it is not shown. Second is self-weight, which is shown as W vertically downwards at the center. Third thing which we are going to show is reaction from contact surfaces. Now, regarding contact surfaces, the number of reactions will be equal to number of contacts. And second thing which you have to remember is reactions will be always perpendicular to the surface and the direction to be shown from the surface towards the body. I repeat again, for the reaction from the surfaces, the reaction to be shown from the surface to the body, the direction part, and it will be perpendicular to the surface. Now, if I observe the figure or diagram AB again, there is a support at this particular point A. So now here the support or the surface is horizontal. So my reaction will be vertical. It should be perpendicular to the surface. So I will make one perpendicular line at A. So this is your reaction. Now regarding the direction it is like, it should be from the surface to the body. It should be directed from the surface to the body. So I will make this force like this. And let us say, is it a normal reaction? So I will write it as N1, reaction from the surface. Another support here, it is at this particular point. Now here you can observe that the surface is vertical. Now because surface is vertical, reaction will be horizontal, that is perpendicular to the surface, and the direction will be from the surface to the body. So the direction will be like this. So I will make the same thing here at particular point B, and I will name it as, let us say, N2. So we have completed the third part wherein we have shown reactions at contact surfaces. Now the last part. Last force which we are going to show in the free body diagram is the friction force. And for friction force, you have to remember, like, friction force is a force which opposes the motion of the body. So it should be shown in the direction opposite to the motion of the body. Now again, if you refer the diagram given in the question for the ladder, this ladder will try to slip. This point A will move towards this side, towards left, and point B will move towards downside. So this is the direction of motions for point A and B. Friction force will be opposite to these directions. So if I make the friction force at point A, the motion is towards left, so the friction force will be towards right side. So I make one force which is on the right side, and I will name it as mu multiplied by N. That is friction force at this particular point. Similarly, at point B, the motion of point B is towards downside. So the friction force acting at point B will be towards upside, and the value will be coefficient of friction, that is mu multiplied by N, the normal reaction at that particular point. So this completes the free body diagram of a ladder supported at points A and B. Now, let us go to the second case, wherein there is a block of weight W again kept at the floor. So if I make the free body diagram, as I said, what is free body diagram? Free body diagram is when we remove all the supports of the body and draw the diagram and show all the forces acting on the body, that is known as free body diagram. So first of all, I will isolate the diagram. So this is my body W, which I have isolated. The first thing to be shown in the free body diagram is the applied force. So here in the given question, you can see that there is a force P which is applied at an angle of 45. So I will show the applied force as it is. So this is force P acting at some angle theta, that is 40. So I have completed my first part, that is show the applied forces. Second part we show is, or the second force which we show in the free body diagram is the self weight. Self weight, as we have discussed, it will be vertically downwards at the center. So I will make one force here in vertically downward direction, and I will name it as W because the weight given is W. So second part is also done. Third part. For third part, it is reaction from contact surfaces. Now in the diagram, you can see that this particular body of weight W is in contact with this particular surface. Now, as the surface is horizontal, the reaction will be vertical, and the direction will be from the surface towards the body. So it will be like this. So I will make this in the free body diagram like this, a force or the reactive force, and I will name it as, let us say, N1. Now the last force to be shown in the free body diagram is the frictional force, and as discussed, it will be the force opposing the motion of the body or opposite to the motion of the body. Again, if you look at the diagram given, because of this load applied P, this body will try to move in this right direction. Now, because the body is moving towards right side, friction force will come towards left side. So I will make one force on the left side, and I will name this as mu multiplied by N1, that is friction force. So this completes the free body diagram of a block kept on a surface. Now let us go to the third case, wherein we have the cylinder of weight W again resting on the surface. So again, for a free body diagram, I will isolate the body from all the contact surfaces. So let us say this is a body which has been isolated, a circle or a disc. The first force which we show on a free body diagram is applied force. So here, if you observe in this particular diagram, there is no applied force given, so we don't need to show any applied forces. Second is the self weight. Self weight to be shown vertically downwards with a weight W. So weight is W and shown vertically downwards. The third force which we show is the reaction due to contact surfaces. Now, this particular cylinder is in contact at this particular point in the diagram, at this particular surface. So now again, as the surface is horizontal, the reaction will be vertical. So I will make this kind of reaction, and the direction will be from the surface towards the body. That means the direction will be like this. So I will just transfer this into a free body diagram. that there will be a normal reaction from the surface, and that will be known as N1. Now the last force. Last force is the frictional force, which is in the direction opposite to the motion of the body. Now let us assume, as the direction of the motion is not given, let us assume that this is moving in the clockwise direction. So when this circle or the disc is moving in clockwise direction, this particular point which is in contact will move towards this side. This is moving towards this side. Now, because the point is moving towards this side, the friction force will be towards right hand side. So I will make a friction force towards right side here, and the value will be again mu multiplied by n. This completes the free body diagram of this particular case. Now, let us go to the next one. The fourth case, wherein there is a block of weight W acting or kept at an inclined plane which is acting at an angle of theta. So again, same procedure we will apply. I will isolate the body from all the contact surfaces. So it is like this, a body kept on an inclined surface. Then starting with the free body diagram, first thing which we have to show is the applied force. So I will show the applied force as it is shown in the diagram. So it is P. Then self weight to be shown vertically downwards. Whatever be the position of the body, self weight will always be shown vertically downwards. So I will make this as a vertically downward force of weight W. Then the third force which we show in the free body diagram is the reaction force. And we know that reaction force or the reaction from contact surface is always perpendicular to the surface. Now, if you observe the surface on which the body is kept, the surface is inclined like this. So the reaction perpendicular to it will be in this particular direction, the perpendicular direction. The reaction should be perpendicular and it should be from surface to the body. That means the direction will be like this. So I will just convert or transfer it into free body diagram. So I will get one force here and I will name it as, let us say, N1, reaction from contact surface. It is perpendicular to the surface. And the last one is the friction force. So as it can be seen from the diagram, because of this force applied P, this body will try to move up the plane. Hence, the friction force will be acting down the plane with a value of mu multiplied by. This completes the free body diagram of this particular case. Now let us go to the last case. Body under consideration here is the cylinder. So I will isolate the cylinder from the contact surfaces and all the contact points. So this is the cylinder which is isolated. The first thing which we have to show is the applied force. Now, if you observe this figure correctly, there is no applied force given as such. But this particular body, this entire body which is given in the diagram, is being supported by this particular cable, this cable. So cable will always give the tension force and it should be shown always away from the body. So that can be considered as the applied force and it should be shown away from the body. So I will make a force like this along the thread length. I will name it as tension in the string. Then next force which we are going to show in the free body diagram is the self weight, which we have discussed. It will be vertically downwards and the center. So from center, I will make a vertically downward force and name it as self weight. Then third is reaction from contact surfaces. Now, this particular body is in contact with the surface at this particular point. And the surface of contact is vertical, hence reaction will be horizontal. And the direction will be from the surface to the body, so it will be like this. So transferring the force here, I get this as the force and I will name it as, let us say, N1. Now, regarding the friction force, because this body is not moving with respect to any of the surface, there is no friction which will be coming into picture. So this completes the free body diagram of the object shown. So we have discussed 5 different cases in which we have drawn the free body diagram. I hope you have got the concept of drawing the free body diagram correctly. So just to summarize the things, the free body diagram is a diagram which is made by isolating the body from all the contact. Then to draw the free body diagram, first force which we are going to show is the applied force, or you can say a force in a cable or a string or a thread. That is considered to be its applied force, which has to be shown as shown in the diagram. In case of cable and rope, it should be shown away from the body as the tension. The second force which we are going to show in the free body diagram is self weight. So let me write somewhere. Yeah. So the first force which we are going to show in the free body diagram is the applied force. The second force which we show is the self weight. The third force which we show in the free body diagram is the reactions. And the fourth force which we show is the friction force. So when we complete showing all these forces acting on the body, and the diagram so formed will be known as free body diagram.
Let us proceed to the next question, which says determine the tension in AB and BC for the equilibrium. Here it is given the word equilibrium. Equilibrium means Fx also equal to 0, Fy is also equal to 0. For 30 kg block, again the unit here is given as 30 kg. This is the important things. 30 kg block as shown in the figure. Now if you observe, this 30 kg block is acting on point B. So let us say I will draw a free body diagram of point B. So this is point B. For free body diagram, what we do is applied forces. There is no applied force at point B. Then tension in the strings. So there is one string here. Let us say assume this as tension in string BC. Then there is one string here. I will assume that it is tension in string AC. So AB. Then self weight on B is acting as 30 kg. So it will be 30 into 9.81. This is the important conversion here. It should be 30 into 9.81. Now, what is the observation? Observation says that at a point there are three forces passing, hence Lami's theorem is applicable. So for Lami's theorem, I need angles. So this angle is given to us as 30 degrees, and this angle is given to us as 40 degrees. Now, starting with the Lami's theorem says that force upon sine of angle between other two forces. Let us say if I take this as force first, TAB divided by sine of angle between other two forces. So these are the other two forces now. So it will be 90 plus 40, that is 9 plus 130 degrees. Then second force, let us say I am assuming that TBC, so I get TBC divided by sine of. If this is the force, these are the two remaining forces. So it will be 90 plus 30, that is 120 degrees. And finally the third force, 30 into 9.81 divided by sine of. I need this angle, other two forces. So it will be basically 180 minus 30 minus 40. This 30 and 40 will be subtracted from this entire 180. Angles forming linear pair. So I will get angle as 110 degrees. Sine of 110 degrees. So if I solve taking this and this values, I will get answer for TAB as 239.91 newtons, and when I take this part along with this part, I will get answer for TBC, which is coming to be as 271.22 newtons. This completes the solution. It was asked to find out tension in the rope AB and BC, which we have found out. Let us proceed to the next question, which says, for a system shown in figure, determine the mass M to maintain equilibrium. Again, equilibrium is given here. To maintain equilibrium. Now, if you observe, there are 2 points on which the mass are attached. One is point B and one is point C. So I will make two free body diagrams. One will be for point B, free body diagram for point B, and one will be for point C. Okay, starting with point B. So for point B, there are two strings attached. So let us say TBC and TAB. These are the two strings attached on point B. So TAB, and then we have the load of 5 kg attached here. So it will be downward force of 5 into 9.81. Again, important conversion. 5 into 9.81. Then at point C, there are forces acting. So this will be force TCD, tension in force cable CD. Then we have another cable passing from C to B. So this will be TVC. And there is one load acting here of mass N kg. So it will be N into 9.81 because it is kg. Now, what is observation? Observation says that there are three forces acting at point B as well as point C. So, if three forces are acting, you can apply Lami's theorem. But for Lami's theorem, we need angles. So, now let us calculate the angles first. This angle is already given to us as 30 degrees for TBC. This is 30. Now, for this force, angle is directly not given, but we are given the lengths as 3 and 4. So if I assume that this angle is alpha, I will get alpha is equal to tan inverse of opposite, that is 4 upon 3. So I will get alpha angle as 53.13 degrees. So we got this angle as 53.13. Now for this case, this angle is already given to us as 70 degrees. And this TBC, as this angle is 30, this angle will also be 30 degrees, vertically opposite angles. So this is also 30 degrees. Now we can apply Lami's theorem on both the sides. So let us say if I apply Lami's theorem on point B, what I will get is TAB divided by sine of, if I am taking AB, I need this entire angle. So it will be 90 plus 30, that is 120. Then second case, we have TBC divided by sine of, if I am taking TBC, I need this entire angle. So it will be 90 plus 53.13. So it is 143.13. And third, it will be 5 into 9.81 divided by, I will need this entire angle. So it will be 180 minus 53.13 minus 30, which I will get answer as 96.87. So it will be sine of 96.87. So when you solve these equations, let us say if you solve this two, you will get answer for TBC, and once you solve this two, you will get answer for TAB. So I will write the answers here. TAB you should get as 42.78 newtons, and TBC you will get as 29.64 newtons. This completes the solution for point B. Now for point C again, we will apply Lami's theorem because here also there are three forces passing through one single point. So starting with TCD divided by sine of, if it is CD, I need angle between other two forces, that means I need only this angle. So it will be 90, the total 90 minus 30. So it will be 60, sine of 60 is equal to, then I will write TBC divided by sine of. So if this is the force, this is the angle. So 90 plus 70, that is 160, equal to m into 9.81 divided by sine of. If this is the force, this is the angle required. So this angle will be how much? If this is 70, this one will be 110. Angles forming linear pair. So now the total angle becomes 110 plus 30, which is 140. So now again, if I take this two, I will get answer for TCD sorry, first we need to take this two. Once we take this two, we already have the answer for TBC here. So let us say if I take this two part, if I take this two and solve, I have the value of TBC, I will get the answer for M. So I am getting answer for M as 55.70 newtons. 55.70 newtons. Okay. Then if I use this two, TCD and this, I will get answer for TCD as 75.05 Newton. This is not required to be found out, but okay, we can find out this also. But important thing, students leave the question here. They think that M we got answer as 55.70 Newton. But remember that we are in the question we are asked to find out mass N, and we are finding out in newtons. That means we are finding out weight of this. So what we need to do is we need to find out mass as mass is equal to 55.70 divided by 9.81 to convert it into kgs. Therefore, we get mass is equal to 5.68 kgs. This is the final answer. Okay, this completes the problem. Let us go to the next question, which says a wheel of weight W is equal to 1000 Newton rests on a smooth inclined plane. It is kept from rolling down the plane by string AC. Find the tension in the string and reaction at point of contact D. Again, it is told that it is kept from rolling down. That means it is kept stationary. If it is stationary, it is in equilibrium. So if it is in equilibrium, we can use summation of fx equal to 0 and summation of fy equal to 0. Okay, starting with the free body diagram first. So let us say this is point C or body C, of which we are drawing the free body diagram. The first force which we show is the applied force. There is no applied force here. Then we should have tension in the string. So there is a string AC here. So we will show the force AC. Let us say tension in string AC. Then self weight is given as 1000. Self weight vertically downwards has to be shown. So we completed applied force, self weight. Then reaction from contact surfaces. Now just observe here. As this is the surface, reactions are always perpendicular to surface. So this will be the reaction. And the direction will be from surface to the body. Surface to body. So this will be the direction. So this is RD, reaction at point D. If I convert this here, it will be like this. Reaction at point D. Okay. So this completes the free body diagram. Now, the observation says that there is one point C on which there are three forces passing. That means Lewis theorem is applicable. But for Lewis theorem, we need angles. Now, angles, just look at the diagram here. There is some geometry involved. Now, we know that reactions are always perpendicular. So, in this triangle, reactions are always perpendicular. That means this is 90. If this angle is 90, this is 45. So, this remaining angle will be 45 only. Sum of all angles of a triangle. So this we got angle is 45 degrees. Reaction of D. Now regarding TAC, what students make the mistake? They take angle as 15 degrees and proceed further. This is wrong. The angle for TAC is not 15 degrees. 15 degrees is just the angle between the plane and the string. We need the angle between X or Y. So what I will do is I will make some construction here. Let us say this is the construction. Now just observe that this angle is 45. If this angle is 45 on the left side, this total angle will also be 45 because it is angles forming alternate angles. So this is 45. This total angle, of which this is only 15. So this remaining angle will be 30 degrees. So what we got is the angle of string with respect to horizontal axis is 30 degrees. So the angle of string with respect to horizontal axis is 30 degrees. This is how we got the angle. And once we got the angle, now it is simple. Just write the equations. That is Lewis theorem. So Lewis theorem says that TAC divided by sine of angle between other two forces. That means these two forces. So 90 plus 45, that is 135, should be equal to RD divided by sine of. So RD divided by this angle, so it will be 90 plus 30, that is 120, equal to 1000 divided by sine of this angle. So this will be 180 minus 30 minus 45. So it is around 10. So if I take this 2, I will get answer for RD. If I take this 2, I will get answer for TAC. So I am getting answer for TAC as 732.05 newtons, and I will get RD, that is reaction at point D, as 896.57 newtons. This completes the solution because the two things were asked: tension in cable AC and reaction at point D. Both of them are on the screen. Let us proceed to the next question, which says a sphere weighs 850 Newton is supported by a cable as shown in figure. Find tension in cable and reaction at point of contact with the wall if system is in equilibrium. So here it is given if system is in equilibrium, I can write summation of fx equal to 0 and summation of fy is equal to 0. Now, first step is drawing the free body diagram. So I will draw the free body diagram of the cylinder. So let us say this is the cylinder, and let us say I name the points. Let us say this is center C. Let us say this is A and this is B. Now, starting with the free body diagram, cylinder C, point C. Sub all the forces on free body diagram. The first force we show is the applied force. Here it is there. The force P of 500 Newton is applied at point C. So I will first make the applied force. See the direction of force. It is going downwards. Don't make this mistake. So it is downward force of 500 Newton. Then self weight. Self weight should be shown always vertically downwards. So vertical downward force of 850 Newton because weight is given as in 50. Then reaction from contact surfaces. Before that, one thing we have missed, that is tension in cable. This sphere is supported by cable AC, so there will be tension also, and tension should be shown away from the body. So let us say this is tension in the string AC. Then reaction from contact surfaces. This particular cylinder is in contact with this particular point B. Now surface contact is vertical. Surface contact is vertical. That means reaction should be horizontal. So there will be one horizontal support reaction, that is R. Now what is the observation? Observation says that there are four forces passing through point C. And if there are four forces, then this theorem will not be applicable. So we have to go by condition of equilibrium, that is summation of fx should be 0 and summation of fy should be 0. These two should be the conditions. To apply these conditions, we need all the forces should be resolved in x and y. Now, there are two inclined forces which I can see in the diagram. The first one is this one, so I will resolve it. Draw one line parallel to x, one line parallel to y. Force is going towards left and down, so this will go left and this will go down. See the direction of the forces. If you make the direction wrong, the entire solution will go wrong. For TAC, this is an inclined force. Draw one line parallel to x, one line parallel to y. Force is going left and up, so this will go left, this will go up. Now regarding angles, for angles come to the main diagram. Now for this angle, let us say alpha, for this angle alpha, we have the opposite side and we have this radius as 1. That means opposite side is with us and adjacent side is with us. So I will write alpha is equal to tan inverse of opposite upon adjacent. So opposite is 3, adjacent is 1. So I will get alpha is equal to 71.56 degrees. So this angle we came to know, 71.56. So if this is 71.56, this will be TAC cos 71.56 and this will be TAC sin 71.56. Now regarding this 500 Newton force. We are already given the angle with respect to x is 30 degree. So if this is 30, this is also 30 with respect to x. Alternate angles. So this will be 500 cos 30. This will be 500 sin 30. Now, as all the forces are resolved, now we can apply the conditions of equilibrium. So summation of fx should be 0. Therefore, I will write therefore minus TAC cos 71.56, adding all the forces in x direction, minus 500 cos 30 plus RB should be 0. So from here we will not get any answer, so I will just make it as equation and leave it. So let us say this is equation number 1. Now regarding Fy, adding all the forces in y direction. So for y we have TAC sine of 71.56 going upwards of positive. Then we have minus 500 sine 30. Then we have minus 850. So we have added all the forces in y direction and this should be equal to 0. So if you observe that there is only one unknown in this equation, that is TAC. So I will get the answer for TAC from here, which comes out to be as 1159.47 newtons. And once we got value of TAC, we'll put this value of TAC here in this equation. Now if you observe there is only one unknown, that is RB. So once you solve in your calculators, you should get answer for RB as 799.76 newtons. Okay, this completes the solution.
Next question. Again, I will not read the question. मेरे को कितनी बॉडीज दिख रही है? दो बॉडी दिख रही है, तो कितने फ्री बॉडी डायग्राम बनेंगे? दो. तो देखो यहाँ पर मेरा बन गया पॉइंट नंबर बी और यहाँ पर मेरा बन गया पॉइंट नंबर ए. सी हाउ टू अप्रोच अ प्रॉब्लम, कुछ नहीं है, बहुत सिंपल रहता है, 8 मार्क्स के समय ये सब. हाँ, पॉइंट बी. हाँ बोलो.
यूनिवर्सिटी एग्जाम में ये डायग्राम पूरा कॉपी करके फिर एफबीडी बनाना पड़ेगा.
Yes.
डायरेक्ट एफबीडी
डायरेक्ट भी बना सकते हो, अगर आप कॉन्फिडेंस डायरेक्ट बनाओ. मेरे हिसाब से टाइम वेस्ट मत करो वापस से डायग्राम बनाने का. यू डायरेक्टली गो फॉर एफबीडी.
ओके सर.
चलो पॉइंट नंबर बी. पॉइंट नंबर बी पे सबसे पहले अप्लाइड फोर्स है क्या? कुछ बोलो. हाँ. नहीं है. नहीं है. नहीं है. नहीं है. ठीक है. फिर पॉइंट बी पे दूसरा क्या आता है? सेल्फ वेट. अब थोड़ा सा क्वेश्चन पढ़ना पड़ेगा, हर टाइम अपनी होशियारी नहीं चलेगी ना. वो अपने से होशियार क्वेश्चन देने वाला, बोलता है पढ़ना तो पड़ेगा. टू स्पीयर्स ए एंड बी ऑफ वेट 1000 न्यूटन एंड 750 न्यूटन. तो एक बी का वेट कितना हो गया?
750 न्यूटन.
750 न्यूटन.
750 न्यूटन.
डाउनवर्ड फोर्स 750 न्यूटन. उसके बाद रिएक्शन फ्रॉम कॉन्टेक्ट सरफेसेस. पॉइंट बी का या बॉडी बी का कितने कॉन्टेक्ट है? तीन कॉन्टेक्ट है. कॉन्टेक्ट नंबर 1 हियर एट पॉइंट ए. अरे यार चलना रे. हाँ, कॉन्टेक्ट नंबर 1 हियर, कॉन्टेक्ट पॉइंट 2 एंड कॉन्टेक्ट पॉइंट 3. तीन जगह पे कॉन्टेक्ट है. सो बिकॉज देयर आर 3 कॉन्टेक्ट पॉइंट्स, देयर विल बी 3 कॉन्टेक्ट रिएक्शंस. अब रिएक्शन देखते आएंगे कैसे. अब तो तुम मास्टर हो गए इसमें. पॉइंट ए या पॉइंट 1, सॉरी पॉइंट 1, द सरफेस इज वर्टिकल, तो रिएक्शन कैसे आएगा?
Horizontal.
फ्रॉम सरफेस टू द बॉडी. सो आई विल नेम दिस एज R1. बराबर है?
यस बराबर.
Yes, sir.
Regarding R2, the surface is horizontal, so reaction will be vertical. And from surface to body, that means my reaction will be like this. This is my R2. किसी को doubt?
No, sir.
Now regarding R3, now our body under consideration is this one. ये अगर बॉडी है तो ये हो जाएगा सरफेस. So it will be from surface to the body and towards the center. That means the reaction will be somewhat like this. Yes?
Yes, sir.
Okay, so it will
Yes,
be
sir.
like this.
Green, please.
R3. R3. नाफे को बुला, लेक्चर रखा है. बैठ रहा. हाँ. Okay, so we have completed the free body diagram of B. Now let us have free body diagram of A.
सबको ज्वाइन करवाना है इसका। लेट अस हैव फ्री बॉडी डायग्राम ऑफ ए। ए पे क्या क्या है? सबसे पहले अप्लाइड फोर्स कुछ दिख रहा है?
अप्लाइड फोर्स
अरे कहाँ है
नहीं है।
अप्लाइड फोर्स? नहीं है। हाँ मैं टेंशन में आ गया, मेरे को क्यों नहीं दिख रहा है? हाँ अप्लाइड फोर्स नहीं है। सेल्फ वेट है,
यस सर है ना।
1000 न्यूटन गोइंग वर्टिकली डाउनवर्ड्स। उसके बाद रिएक्शन फ्रॉम कॉन्टेक्ट सरफेसेस, बताओ रे बाबा कितने कॉन्टेक्ट सरफेसेस है?
दो
One
सरफेस
contact
है।
surface.
There are
हाँ,
only
दो,
2 contact surfaces. One contact
Yes, sir.
surface is this one, point number 4,
3 and 4.
और
3 and
दूसरा
4.
3 है, ठीक है। So for 4 we know that, what we know that the reactions are always perpendicular. तो ऐसा कुछ बनेगा,
परपेंडिकुलर।
Yes, sir.
यस
Okay.
सर।
तो somewhat like this, अगर मैं ऐसा बना दूं, वहां की चीज को यही बना दिया R4। और रिगार्डिंग R3 हमने ऑलरेडी देख लिए कि नाउ आवर बॉडी अंडर कंसिडरेशन इज ए। अगर ए बॉडी है तो बी सरफेस है, सो द रिएक्शन विल बी लाइक दिस, सो इट विल बी समवॉट लाइक दिस R3। अरे
यस
हो गया।
सर।
अभी पॉइंट ए चिल्ला चिल्ला के तुमसे क्या बोल रहा है?
Lami's theorem apply.
Lami's theorem apply।
यस, लेमिस थ्योरम अप्लाई
एंगल
करो।
फाइंड करेंगे ना।
तो फॉर लेमिस थ्योरम वी नीड टू फाइंड आउट एंगल्स। अब थोड़ा सा ध्यान देना, जिसका मैंने तुम लोग को ऑलरेडी शॉर्टकट बता चुका हूं कैसे दिमाग लगाएंगे। क्या दिख रहा है? इंक्लाइन लाइन दिख रही है, बराबर।
इंक्लाइन लाइन।
इंक्लाइन लाइन जहां दिखी क्या बनाएंगे?
ट्रायंगल बना ले।
Triangle.
ये लो बना दिया, ट्राइंगल बन गया।
बना दिए। यस सर।
उसके बाद क्या करेंगे? हाँ ये
60 डिग्री है तो
ये रेडियस कितना है छोटे वाले का?
कितना है?
अभी हो गए मुझे 4.25 हो गए।
150। अरे 150।
हाँ 1 2 3, ये छोटे वाले का रेडियस कितना है?
300।
क्वेश्चन में दिया है,
300
देखो रेडियस ऑफ बी इज 300, तो दिस इज 300। और बाजू वाला 400। तो दिस टोटल डिस्टेंस, अगर मैं बाहर ये डायग्राम बनाऊं, अगर मैं ये डायग्राम, ये ट्राइंगल बाहर बना दूं, सो दिस इज टोटल 700। किसी को डाउट? पॉइंट ए, दिस इज पॉइंट बी, और इसको नाम, अपना नाम रख दो, लेट अस से एन, मैंने रख दिया, ठीक है। अब मुझे या तो हाइट चाहिए या तो बेस चाहिए, मैं क्या किस पे टारगेट करूंगा? बेस पे। बेस पे इसलिए टारगेट कर रहा हूं बिकॉज मेरे पास बेस के रिलेटेड में डायमेंशन है यहाँ पर ऊपर 700, ठीक है, इसलिए।
यस सर।
अब कैसे करेंगे? यस
700 माइनस
700 माइनस
रेडियस ऑफ बी।
करेक्ट, इट्स वेरी सिंपल। देखो क्वेश्चन में हमको दिया है कि यहाँ से यहाँ तक कितना है? 700, बराबर। उसमें से हमको मालूम है कि ये जो रेडियस है ये 300 है, तो ये बचा हुआ कितना होगा? 400। समझ में आ रहा है?
यस।
तो दिस इज 400। क्या इक्वल है? हाँ देखना, पैरेलल लाइन है ना दोनों।
ए का एच।
हाँ मैं पैरेलल लाइन बनाया ना, वहां से स्ट्रेट लाइन ही तो नीचे किया मैं।
ऐसा थोड़ा ज्यादा दिख रहा है इसलिए।
नहीं दिखा मत तू, स्ट्रेट लाइन बना, तो दिखने में छोड़ दे, तू स्ट्रेट लाइन बना तो सही दिखेगा, ठीक है। नाउ कैन यू टेल मी व्हाट इज दिस एंगल?
55.15
सर।
cos थीटा इज इक्वल टू 400 अपॉन 700, तो थीटा कितना आ रहा है?
55.15।
55.15। किसका एंगल? ये वाले का एंगल, कॉमन रिएक्शन वाले का। तो कॉमन रिएक्शन का एंगल क्या था? R3। मतलब ये एंगल हमको दिया हुआ है 55.15, दिया हुआ नहीं है, हमने फाइंड किया। एंड दिस एंगल इज ऑल्सो 55.15। अब कौन सा एंगल बच गया? R4 का। उसके लिए भी सिंपल लॉजिक, हमको क्वेश्चन में दिया है दैट दिस एंगल इज 60 डिग्री, करेक्ट? द एंगल ऑफ प्लेन, ये तरफ। हमको मालूम है कि रिएक्शन इज ऑलवेज परपेंडिकुलर, मतलब दिस इज 90। तो अगर ये 60 है, ये 90 है, तो ये बचा हुआ कितना रहेगा बेचारा?
30।
विथ रिस्पेक्ट टू विच एक्सिस?
30
एक्स। तो यहाँ पर भी आ जाओ, मेन डायग्राम में बना दो विथ रिस्पेक्ट टू एक्स 30 डिग्रीज। अब क्या लगाओगे पॉइंट ए पे? लेमिस थ्योरम लगा लोगे?
यस सर।
फटाफट लगाओ और आंसर बताओ। व्हाट इज द आंसर फॉर, आई नीड आंसर फॉर R3 एंड R4। अप्लाई लेमीज थ्योरम इन पॉइंट ए, ऑन पॉइंट ए. चलो यार मैं भी लगा देता तो तुम लोग लंबा करोगे. R4 डिवाइडेड बाई साइन ऑफ 9 plus 5 14 145.15. R3 divided by 90 plus 30 sine of 120 is equal to 1000 divided by sine of 50 60 70 80 85.15. तो कितना बचेगा
180 माइनस कर दो.
94.85
92 के 94.
94
हाँ, मतलब मैंने बराबर
94.85
लिखा. ओके, सो R3 एंड R4 आंसर.
R3 सर 869.13.
हाँ, इतना बड़ा.
हाँ 1000 है ना सर.
अच्छा हाँ, यहाँ 1000 है. ओके, 869.13 न्यूटन. एंड व्हाट अबाउट R4? बोलो.
R4 में जो 30 है 30 से लिए ना आपने.
कौन सा? हाँ हाँ, ये R3 का रिएक्शन ना, R4 का, सॉरी R4 का.
R4
60 देखो 60 दिया हुआ था, 90 हमको मालूम है दैट रिएक्शंस आर ऑलवेज परपेंडिकुलर, तो ये बचा हुआ एंगल 30 होगा. हाँ, R4
सर 573.48.
ओके, 573.48 न्यूटन. ठीक है, अभी पॉइंट ए तो कंसिडर हो गया. पॉइंट बी भी मेरे को चिल्ला चिल्ला के बोल रहा है मुझे लेमिस थ्योरम लगाओ. लगा दूं?
नहीं सर, नहीं
सर?
लगेगा.
नहीं.
अच्छा, नहीं बोल रहा है तो दूसरा तरीका
उसमें
क्या है?
4 है. 4 फोर्सेस इक्विलिब्रियम है.
ओके, सो उसमें भी एक टेढ़ा बनता है, उसको क्या करेंगे?
रिजॉल्व.
हाँ, रिजॉल्व में सीधा कर देंगे.
तो सीधा करेंगे.
अपन इंग्लिश में बोलते हैं
सीधा.
हाँ, R3
सीधा करें.
cos 55.15, R3 sin 55.15. So now directly I will write summation of fx equal to 0. Add all the forces in x direction. R1 minus R3 cos 55.15 is equal to 0. जिसमें से R3 मुझे पता है, यहाँ पर डाल दो तो क्या मिलेगा? R1 is equal to तो करो
496.64.
496.64 न्यूटन.
64.
ठीक है. सिमिलरली इफ आई गो फॉर समेशन ऑफ fy, सो fy में क्या क्या आ जाएगा? R2 माइनस R3 sin 55.15 माइनस 750 इक्वल टू 0. तो यहाँ पर भी मुझे R3 मालूम है, उसको भी यहाँ लाके यहाँ सब्स्टिट्यूट कर दो. सो द ओनली अननोन इज R2. सो व्हाट इज R2?
1463.25
1463.25.
newtons.
Now you can read the question. क्या पूछा था? Determine the reaction at all contact points. तो contact
R1,
points
R2,
1, 2,
R3,
3, 4. R1, 2, 3 and 4 चारों आ गए?
हाँ सर आ गए सर.
Yes, sir.
This completes the
आ
problem.
गए.
Determine reaction at supports A and E. So basically this is a question of support reactions of a beam. So what we need to do is I will make the same beam again down and I will make a free body diagram for this. Now for a free body diagram, just say this is point A, B, C, D and E. Now starting with the free body diagram. In free body diagram, first we make the forces as it is. So this is the force which is given. So I will make this force as it is, that is 5 kilonewton. Then this is the force of 4 kilonewton acting at an angle of 30 degrees. So these are the applied forces. Then we need to convert all the loadings into reactions. So here I can see from point D to point E. From point D to point E, that is in a span of 5.4 meters, 5.5 meters, there is a UDL of 6 kilonewton meter. So this force of UDL will be converted into one support reactions or a load of value 6 into 5.5. acting at a distance of 5.5 by 2, that is 2.75. So it will be 2.75, that is exactly at the center from A also, from D also, and from E also. So this force value will be 6 into 5, 35, and the total value will be 33 kilonewton. This value of force will be 33 kilonewton. So applied forces, then convert the loading into reaction, then we have convert the supports into reactions. So here there is a hinge support. For hinge support there will be two reactions. Let us say it will be VA and HA. The direction you can assume anything here. Similarly, at point E there is a roller support. So roller will offer one reaction vertical, that will be VE. This completes our free body diagram. Now before applying conditions of equilibrium, we need to resolve all the forces which are inclined. So here it is an inclined force. So draw one line parallel to X, one line parallel to Y. Force is going down and right, so right and down. Angle is 30 degree with respect to X axis. So because it is with respect to X axis, X will be cos. So this will be 4 cos 30. This will be 4 sin 30. That's it. I will just write the values of 3 meters, 4 meters, 1.5 and 5.5. Once you draw this free body diagram correct, then the solution is very simple. We need to just now apply three lines, three equations, fx equal to 0, fy equal to 0 and moment equal to 0. That's it. For any question of support reaction, this will be the steps. So first step, let us say summation of fx should be 0. Add all the forces in x direction. So x, it is HA going right side, then plus 4 cos 30 again going right side is equal to 0. So from here I will get answer for HAS. HA is equal to 3.464 newtons minus, or I will get, or if it is coming minus, so I will do it, HA is equal to 3.464 going in the opposite direction. We have assumed it towards right, but it will not be towards right, it will towards left, because we got answer as negative. Then second condition is summation of Fy should be 0. Add all the forces in y direction. So we have Va minus 4 sin 30, then minus 5, then we have minus 33, then we have plus V. So taking all the unknowns on one side and others on other side, so I will get Va plus Ve equal to, the all the things will go on the right hand side, so we will get answer as 40. Let this be equation number 1, because we are not getting the answer directly. Then we have third equation, that is summation of moment. Now here you can take moment about any point on the force. Take moment about any point on the beam. So simple is to take the moment on the point which has maximum forces. So let us say point A. So I will write moment about point A should be 0. This force is passing through point A, moment will be 0. Then VA is also passing through moment, point A, moment will be 0. If you observe this 4 cos 30, this also line of action is passing through point A, moment will be 0. So starting with this part, this is making a clockwise movement, so it will be minus 4 sin 30 into distance is 3. So clockwise movement, it will be minus. Then we have this force again making a clockwise movement, so it will be minus of 5 into distance will be 3 plus 4, that is 7 from point A. Then we have this force again making clockwise movement, so minus 33 into distance from point A will be 3 plus 4, 7 plus 1.5. 7 plus 1.5 is 8.5. 8.5 plus 2.75. So it is coming out to be as 11.25. Then we have VE, which is making a anti-clockwise movement, so plus VE into distance is 14. This all should be equal to 0. Now if you observe, there is only one unknown in this entire equation, that is V. So once we solve it, I should get answer for VE as 29.44 kilonewton. And once we got VE, put this value of VE in this equation. So I will get answer for, therefore VA is equal to 10.56 kilonewtons. Now, most of the students leave the question here, assuming that they have solved all the, or they have found out all the reactions. But if you see the question, determine reaction at support A reaction. They are not asking us to find out what is horizontal reaction at A and vertical reaction at A. They are asking us to find out what is the resultant reaction at point A. So I will write RA is equal to root of, it will be HA square plus VA square. So it will be square root of HA square, that is 3.464 square plus 29.44 square. So I will get, therefore RA is equal to, resultant at point A will be equal to 11.11 kilonewton. Again, this is just a magnitude. We also need to find out direction. So I will write theta A is equal to tan inverse of VA upon HA in modulus. So it will be tan inverse of VA. VA we got as 10.56 and HA we got as 3.464. So this will be equal to 71.83 degrees. So this completes now the solution. Now you must be wondering, I have done for this for point A only, why not for point E? So if you observe at point E there is only one reaction, so we don't need to find the resultant because there is only one reaction. So final answer, reaction at point E is VE, that is 29.44 kilonewton, and reaction at point A is a combination of HA and VA, so that will be RA, which is equal to 11.11 kilonewton acting at an angle of 71.83 degrees. This completes the question. So let us move to the next question, which says, so next question is, a beam is loaded and supported as shown in the figure. Find the support reactions at point B if the and force P if the reaction at support A is 0. So as the first step, we will again draw the free body diagram first. So for a free body diagram, I will use the same thing: A, C, D, B, E, and F. The dimensions are 2 meters, 1 meter, 3 meter, 1 meter, and 2 meter. In free body diagram, first we show the applied forces. So applied force at point C, it is shown. So at point C there is a force of 40 kilonewton, and also there is a couple of 20 kilonewton meter. Then there is an applied force at point E of magnitude P, which will be shown here. Then after making the applied force, we go for converting the supports into reactions. So here it is at point A, there is a hinge. So hinge will be replaced by two reactions, let us say VA and HA. And at point B there is a roller support, so it will be replaced by one reaction, let us say it is named as VB. This completes the second step. Third step, convert all the loadings into reactions. So here you can see there is a UVL. So UVL conversion is half into base, that is 3, into height, that is 24. So if you convert this, you will get 36 kilonewton force, and it will act at a distance of 1/3 from right angle side. That is from B it will be 1/3, that is 3/3, which is equal to 1. So from point B at a distance of 1 meter, there will be a force of 36 kilonewton. So this is distance 1 meter. So if this is 1 meter, this remaining will be 2 meters. This completes our free body diagram. Now, before starting the solution, we have to check the condition. It is given that reaction at support A is 0. If reaction at support A is 0, in solution I can write, therefore, as
reaction at support A is 0, I can write HA is equal to 0 and VA is also equal to 0 because it is given in the question. Now, going as per our regular procedure, summation of Fx should be 0. So in Fx there is only one force, that is HA. So I am getting HA is equal to 0 kilonewton. Then summation of Fy should be 0. Add all the forces in y direction. So for y we have VA minus 40 minus 36 plus VB minus P equal to 0, in which VA is already 0, so this is gone. So I will remain with VB minus P is equal to 76. Let this be equation number 1. Then summation of moment. We can take moment about any point, but if we choose it smartly, we will get the answer very fast. So let us say if I choose point A, there is no meaning because HA and VA is already 0. So let us say in this case, I will choose either point B or point E for moment. You can choose any of the point, but for this case, we can go either for B or E. So let us say I am going for E this time. So I will write moment about E is equal to 0. You can choose, again I repeat, you can choose any of the point on the B. So if I take moment about P, this HA is passing through point P only, so moment will be 0. For VA, VA is making a clockwise movement, but HA and VA itself are 0. So if reactions are only 0, there will be no movement. Now for this force, with respect to point E, it is making a anti-clockwise movement. So it will be positive 40 into distance from point P. So it will be 1 plus 3, 4, 4 plus 1, 5. So it is 40 into 5. Then there is a couple, clockwise couple. So it will be minus 20. Then this force is making again an anti-clockwise movement. So it will be plus 36 into distance from point P is 1 plus 1, that is 2. Then we have VB, which is making a clockwise movement, so it will be minus VB into distance from point P is 1. And then we have force P, which is passing through point A itself, so movement will be 0. So everything we have considered, this all should be equal to 0. Now if you observe, the only unknown in this equation is VB. So on solving it, I will get answer for VB as 252 kilonewtons. And once we got VB, put this value of VB here, and I will get answer for P as 176 kilonewtons. So these are our final answers. In the question, it was asked to find out reaction at support B and force P. So this is reaction at support B, that is VB, and this is the value of P. Let us move to the next question, which says find the reaction at supports A and B for the given beam as shown in the figure. Again, first I will convert it into a free body diagram. So, some applied force, there is an applied force at B, 40 kilonewton. So I will make it as it is, applied forces. Then there is a couple here of 80 kilonewton meter. Then there is a force here also. So this force will be shown also as it is, 100 kilonewton. So these are the applied force which are shown. We name them A, B, C, D, E. Okay. We also write distance 3 meters, 2 meters, 2 meters, 2 meters, 1 meter, and 1 meter. Okay. So applied forces are done. Then we convert all the supports into reaction. So if you observe at point A, there is a hinge support. So there will be two reactions there. One will be VA, other will be HA. Then we have roller at E. Roller will be replaced by one reaction. So let us say it is VE. Then convert all the loadings into reactions. So here there is a UDL. UDL will be converted into point load by value of 20 into distance is 3. So 20 into 3. There will be force of 60 kilonewton, that is 20 into 3, acting exactly at the half of distance. So this will be 1.5. So if this is 1.5, this is also 1.5. Now we have completed our free body diagram, but before applying conditions of equilibrium, all the inclined forces should be resolved. So here you can see there is one inclined force at an angle of 60 degree. So this should be resolved. Component will go down. So this will be 100 cos 60. This will be 100 sin 60. Now starting with the equations, summation of fx should be 0, adding all the forces in x direction. So HA is going right side positive and 100 cos 60 is coming left side. So 100 cos 60, this should be equal to 0. So from here I will get HA is equal to 50 kilo Newton. This is the answer. One of the answer. HA is equal to 50 kilo Newton. Then we will write summation of Fy should be 0, adding all the forces in y direction. So YA, VA minus 60 minus 40 minus 100 sin 60 plus VE should be 0. So if I take all the unknowns on one side, so I will get VA plus VE is equal to 186.60. Let this be equation number 1. Now the third point or the third equation is summation of movements about any point you should take, it should be 0. So let us say I will take point A as there are two forces on this. So I will go for movement at point A equal to 0. So if it is movement at point A, HA and VA will become 0 because they are passing through same point. This force is a clockwise force, so it will be minus 60 into distance will be 1.5. Then this force is also clockwise, so minus of 40 into distance from point A is 3. Then there is a couple, clockwise couple, so minus 80. Then important part, this force 100 sin 60 is making a clockwise movement, so it will be minus of 100 sin 60. What about distance? Again remember the basics. Movement is force into perpendicular distance. So if the force is vertical, if the force 100 sin 60 is vertical, we need horizontal distance from point A. So from point A to this part, it is 3 plus 2 5 plus 2 7 and this one. This one. So total 1 plus 2 3, 3 plus 2 5, 5 plus 3 8. So into 8. Then for this force 100 cos 60, this is making a clockwise movement. Sorry, anti-clockwise movement. So it will be plus 100 cos 60 into, as the force is horizontal, we need distance vertical, and vertical distance is given here as 1 meter. So into 1. Then we have VE, which is going again anti-clockwise, so it will be plus VE into distance. Distance from point A, so it will be 3 plus 2 5 plus 2 7 plus 2 9 into 9. This all should give you 0. So you can see that there is only one unknown in this particular equation, that is VE. So on solving, we will get answer for VE as 103.64 kilonewtons. And once we got VE, put this value of VE here in this equation to get answer for VA. So I am getting VA answer as 82.95. 82.95 kilonewton. Okay. So most of the students leave the answer here, but if you see the question, it is given that find reaction at supports A and B. So if you observe at support A, there are two reactions, HA and VA. So we need to find out resultant reaction at A, that is RA, is equal to square root of HA square plus VA square. So HA is how much? 50. So it is root of 50 square plus VA is 82.95. So 82.95 square. So I am getting the answer as 96.85. 96.85 kilonewton. So this is RA and this is just the magnitude. So I will also have to find theta A. Theta A is equal to tan inverse of VA upon HA. So this is equal to VA, that is 1 tan inverse of VA, that is 82.95 divided by HA, which is 50. So I am getting answer as 58.92 degrees. This completes the problem. Now if you ask me that why we are not going for B like this, so if you see at point B, oh, there is a mistake here. It is find the supports at A and E. Okay. So at point E there is only one reaction, that is B. So directly we have got the answer for B here. So one of them is this answer, B, direct answer, and one of the answer is this one, theta A and RA. This completes the question. Moving forward with the next question, which says again determine reactions at hinge support and roller support as shown in the figure. So as usual, I will first convert this into a free body diagram, that is into the point loads. So point A, then point B, and point C. First, show all the applied forces. There is no applied force. There is just a couple here. So I will show couple as it is 10 kilonewton meter. Then convert all the supports into reactions. So there are two supports at point A. There is a hinge support. So it will be converted into two point loads. That is VA and HA. Then at C there is one support, that is roller support. So it will be replaced by one reaction. Roller replaced by one reaction. Let us say VC. Then convert the loadings into reactions. So here you can see there is a UDL here. So UDL value is intensity into length. So 1 into 3, that is 3 kilonewton force acting exactly at the center. So I will make this force here. Value of force is 3 kilonewton. At the center means this distance will be 1.5. If this is 1.5, so this also will be 1.5. And this is 2 meters. Then this is also 2 meters. And this is 3 meters. Okay. Now regarding this part, if you see it is a trapezoidal load, it is a combination of UDL and UVL. So for a UDL, for this part it is base into height. So 1 into 3, that is 3 force, a force of 3 kilonewton, acting exactly at the center. That means the distance from here it will be 1.5. Now regarding UVL, just observe carefully, the students may mistake here. Regarding UVL only is this part. Only this part is UVL. So first we need what is the height of this. So 5 minus 1. The height of this UVL is 4, or the intensity of this is 4 here. So the value of force will be half into base. Base is entirely 3. This base is entirely 3 into height is 4, or intensity is 4. So 2 and 2 shows 6 kilonewton force acting at a distance of 1/3 from right angle side. So from this side, right angle side, it will be 1 meter. So I will make the force here, and I will say that the value of force is 6 kilonewton, and it is 1 meter from this end. So if this is 1 meter from here, it will be 2 meters from this end. This was the important conversion in this particular question. Now, as usual, we will start with the summation of fx. So summation of fx should be 0. So adding all the forces in x direction. So I will have HA. There is only one force, so directly I will get HA is equal to 0 kilonewton. Then summation of Fy is equal to 0, adding all the forces in y direction. So we have Va minus 3, minus 3, minus 6 plus Vc equal to 0. So I will get Va plus Vc is equal to 12. Let this be equation number 1. Now regarding movement you can take at any point, but I can see here that there are two forces at this point A, so I will take movement at point A itself. Summation of movement at point A should be 0. So these two forces passing through same point A, movement will be 0. This is making a clockwise movement, so it will be minus of 3 into distance from point A is 1.5. Then there is a couple, clockwise couple, so minus 10. Then this force is again making a clockwise movement, so it will be minus of, value of force is 3, distance from point A will be from here to here it is 3, then 2 5, then 2 7, 7 plus 1.5, so it will be 8.5. Then this force again making a clockwise movement, so it is minus, value of force is 6, distance from point A again same, it will be 3 plus 2 5 plus 2 7 plus 2, that is 9. And for last VC, it is making a anti-clockwise movement if you see. So it is plus VC into distance will be 10. So if you observe here now, the only unknown is VC. So if I substitute values in the calculators and solve, I will get answer for VC as 9.4 kilonewtons. And if VC is 9.4, put this value of VC here to get answer for VA, which I will get it as 2.6 kilonewtons. Now regarding if you want to find out the resultant reaction, so if I see here, when you got answer for HA is equal to 0, when you got answer for HA is equal to 0, that means this force is not there. If this is not there, there is only one force VA, so this will be only the resultant reaction at A. So we don't need to find out any other thing. So the answers are VC is equal to 9.4 and VA is equal to 2.6 kilonewtons. That's it. So this completes the question. Thank you.